All right, so we're going to look at analog to digital conversion today. And so before we do that, we want to kind of understand what analog and digital mean. So you could think of analog as taking measurements of things. So anything that you can take a measurement of generally is going to be analog. And that what that means is there's kind of like an infinite range of values. Okay, so when we have analog, we have some kind of infinite range of values. We call it, when I say infinite, what I'm thinking of is that you can have an infinite number of values in between 2 points. So like if this is 0 inches and this is 1 inch, you can take a measurement anywhere along here and it's going to be a different measurement, right? And so we can go get more and more precision. I mean, eventually you'll get to like a smallest measurement if you had like really sensitive material, like measurement tools and stuff. But the idea is that this being analog, it's a continuum of lengths, and there's no like not really like discrete values where it jumps, like counts by. Okay. Digital, on the other hand, is where we assign things states. Okay, and so the most common one is just having something that can be on/off. Okay, so we're thinking of having fixed states here. Okay, so an example could be like your light switch. So you can turn it on, you can turn it off. That's an example of digital. You know, if you have like a dimmer, that would be maybe an example of something that's analog, where you can control the brightness gradually by changing the value of the dimmer. Okay, and so those are in contrast with each other. And microcontrollers are digital. They only have on or off states. And so when you read the input on a pin, what you're doing is you're measuring a voltage, and really you're doing a comparison. And so for the Pi, high voltage is 3.3 volts, and low voltage is 0. And so if you apply a voltage on a pin, and you're reading that as an input, you know, you could apply like a range of voltages on it, and it's going to register anything like below this point as a 0, and then anything above that point as a 1, and then the middle is kind of ambiguous. It might go either way. Okay, and so that's kind of how like the the inputs work, right? When we have special inputs that are called analog inputs, and the way that those work is instead of just calling it 0 or 1, it's going to take this kind of analog signal and it's going to compare it, like it's going to find the voltage there, and it's going to map it to a value on like a digital range. And so we're going to have some level of like steps here, and basically we're going to climb these steps until our voltage matches with that one right there. And that's how we determine the voltage. Now, the number of steps that you have gives you more precision. So if you have what's called an 8-bit ADC, then you have 2 to the 8th steps between 0 and 3.3 volt that you could divide in. And so 2 to the 8th is about, we'll do the math here. It's about 256. You have 256 steps. Okay. On the other hand, if you have on more precise ADCs, you might get more precision. And so, for example, on the Raspberry Pi Pico, we actually have a 16-bit ADC. And so this is to the 16 steps, which is about 65,536, whereas this one was 256. Okay, and you can see, so we have a lot more precision here and get a lot cleaner measurement than something that would be like an 8-bit ADC. Okay, and so it's going to take that range, it's going to divide it up on those values, and it's going to give you back a number that represents a position in that range. And so the number you get back will actually be the the value. It's going to be between 0 and 65,535, that's what you're going to get back. Okay, and then I think it can actually get you the voltage back too. So I think there's a way to get the voltage, which would be between 0 and 3.3 volts, and the precision is 1 over 65,535. Okay. All right, and so on the Raspberry Pi Pico, we have actually 5 of these ADCs, which are analog to digital converters. They have a precision of 16 bits, which means that they have a range of 0 to 65,535. Okay, and of those 5, we have access to 3 of them. Okay, so one of them is used to measure the temperature of the microcontroller. Another one is used to measure like the input voltage, like that's powering it. And so we have access to 3 ADCs on the Raspberry Pi Pico, so we can take 3 analog measurements. So looking here on our diagram, we can see that we have the 3 of them are right here. So GP26 is ADC 0, GP27 is ADC 1, and GP28 is ADC 2. And those are the 3 ADC that we have available to us. And so we'll start by using GP26 right here. So in this diagram here we have a potentiometer, and this is a type of analog sensor. It's like a dial, and you turn it, and there's what's called a voltage divider in here made of 2 resistors, or really basically it's like a variable resistor in a sense, and it has a voltage divider inside, and by changing the resistance you're changing the voltage that you read. And so this is a tool that you can use to input information, and so like it's often they're used to control things and things like that. And so when we hook it up, we're going to connect ground to ground. We're going to connect one of these outside pins to ground, one of the outside pins to the voltage input, so 3.3 volts, and the other middle pin is going to go to that analog input like that. Okay, and so that's how we wire it up. And then to code it, we'll come over here, and what we're going to do is we're going to say from machine import pin, and then we're also going to import the ADC package. Okay, and then from here we'll say let's import time as well. And so now what we'll do is we're going to create an instance of an ADC. So we'll call it ADC or analog in, and we're going to say analog in equals ADC. I'm going to say pin 26 and mode. I'm going to say pin dot in like that. Okay. I'm going to say while true. We're going to take readings of this, so we're going to say print, and we'll say ADC dot read U16 like that. Okay, and then what you should see is, gotta make this all caps. Oh, it's all lowercase. Never mind. That wasn't the mistake. This was the mistake. All right. ADC isn't defined. Oh, this should be no. It's all caps. Oh, right here. We call the analog in. There we go. And now we run it. And now we're getting these values. Okay, and if we mess with the pin, we might get to change. Grab it here. Make sure I'm on the right one. I killed something here. Let's try to move it down to there. I had mine connected to the wrong pin, I think. So let's try that. Okay, well, mine's connected wrong, but you can see those values coming out. That's that ADC value. And now if you wanted to grab that value, you might say ADC equals, like that. And then we'll call that ADC value. And then you could say maybe like if ADC value is greater than, 35,000, we can, have an instance of an LED maybe, right? So we're going to say LED equals pin 0 pin dot out. And then if it's above that value, we could say LED dot on, or we could say else LED dot off. And now we can actually control that LED with our potentiometer. Okay. And then one last thing. Oh, well, let's print it too. Print ADC value. Okay, and now we can control our LED as well. And then one last thing we want to do is we want to get the voltage, so we can say ADC volts. And what we're going to do is we're going to say ADC value times 3.3, and then we're going to divide by 65,535. Okay? Oh, and then let's print it too. So we'll say comma ADC volts like that. There you go. We see the voltage right next to it. Okay.